Okay, I'm going to show you how the rearrangement inequality works in works in a real case. I'm going to prove that a cubed plus b cubed plus c cubed, this is a, b and c are all positive, is greater than or equal to a squared b plus b squared c plus c squared a. Now that's quite a tricky inequality in its own peculiar way. But what I'm going to do is I'm going to assert that a is greater than or equal to b is greater than or equal to c. And a mathematician would say W log without loss of generality. There's quite a lot going on in that statement there. A greater than or equal to b greater than or equal to c. And you ask yourself, well, what if it isn't? What happens if c is the biggest? Well, you just rename them. So you say without loss of generality this holds, and that might make it easier to do the rest of the work. So if that's the case, then we can also say that a squared is greater than or equal to b squared greater than or equal to c squared, which is nice. So what that tells me is that a squared times a plus b squared times b plus c squared times c is greater than or equal to a squared times something plus b squared plus c squared, where you have a rearrangement here of a and b and c, but shuffled. And of course what I'm going to do is take that b there, I'm going to take that c there, I'm going to take that a there. So we've applied the rearrangement inequality to the sequence a squared, b squared, c squared, and also a, b and c, and we've observed that if that's ordered like that, then so is this one, if and only if that one's ordered, because we're considering only positive numbers. There's quite a lot going on here. A cubed plus b cubed plus c cubed greater than or equal to a squared b plus b squared c plus c squared a. It looks like it's going to be Cauchy's inequality, but it's not. There seems to be something inherent. This inequality seems to be dependent very strongly upon the fact that you can order them. It's quite difficult to prove this unless you make some assumption about the order. So I'm just going to leave that there. I'm going to stop there. Short one, that.